Helen, again, just a huge thank you for coming over today again,
right.
and for taking the time to do this. Again, for the guys and girls who never seen this plane before, and if you can see something in there, you know, that's actually a telescope inside the airplane, which again, SOFIA is the aircraft, and probably some of you maybe heard about it, maybe not. So today's guest, again, Helen Tavora, she's going to be talking about that a little bit more about this project. So again, Helen, thank you so much for joining me.
All right. So hi, I'm Helen. So if you're new in knowing SOFIA, SOFIA is the Stratospheric Observatory for Infrared Astronomy. So that's why you know, it has that cool name, SOFIA. This, by the way, is my grandma's name too.
Hey.
So so I, as instructor of astronomy, I have a huge public. And NASA, normally when NASA does any kind of mission, like space station or the Hubble Space Telescope or any kind of missions, there are always opportunities when the mission is established to bring teachers or instructors to the mission. So in the space shuttle, they had teachers brought to the space station, and the same they are doing with SOFIA. So because I am an instructor and I have eyeballs on me, it's good to have someone who has not just the public, but the communication skills to explain, like I like to say, the gobbledygook of science. So like some of my colleagues there were doing infrared astronomy, they talk in an hermetic manner that you can look at them and like, I have no idea what you just said. So I go in and explain in an easy manner what it means, all the gobbledygook that the other guy who is super genius, has like 3 doctor's degrees, just talk to you. So I go, and my aim is not dumbed down, it's just to get a way to use analogy for the public. So I have from 3 years old at Fox Observatory to some of my students were teenagers in high school, to some college kids who are already doing, you know, they're professionals but come to, and people who are retired here in Florida who come and visit the observatory and want to understand where the tax money is going to. Why you're expending $1 billion in a huge telescope and put in the sky to learn things.
Yeah.
So that's what is my function, not just to bring communication of science to the public, but also to raise the next generation of scientists, or at least people who know enough about science not to believe in myth, to vote in the correct person to represent themselves, or to be representatives of us in politics and government, and not do, you know, the stuff that we've seen lately, that people are believing, you know, in lies on TV. They don't have the analysis of seeing that and knowing that that is totally BS, you know. It's like, because there is no critic in taught in schools anymore. It's like they have a formula, they repeat that formula, and so that's my function. So because I am one of the teachers who are being called to be part of SOFIA's mission, the first thing that I got, we were in a hotel when we arrived in California, so it's Palmdale, where the base is. And then we are in a hotel, and then we have the welcoming and all the teachers. And then one of our instructors, Donna Bachman, one of our, you know, teacher instructors who were going to fly with us, he brought like a bag, and I look at the bag, astronaut jackets. So I start jumping like in the middle of the hotel, and everybody who was coming to the hotel was hugging and kissing, and they go like, who's the crazy lady? You know, it's like, I was so happy. You're like, come on, you dream of it. I've dreamed to be an astronaut. Of course, you know, I cannot hold my cookies for stuff, so I could not be an astronaut. So you know what I mean, holding my cookies. So it's like I get synetosis.
But it sounds funny.
When you cannot hold your cookies, is that you have synetosis. So if you're in motion sickness, so I have big time. So forget about being an astronaut. But I found my way to SOFIA mission, and I got my astronaut jacket.
Hey.
So I have a Babo nationality. So actually I have triple nationality, but here I have the Brazilian flag and the American flag, and then NASA symbol. And then because I am an instructor, whenever you see wings on NASA jackets, you look at the detail of the wings. So in the case of my wing, you can see, I need to put my hand so it disappears. Okay, you can see there is a book right in the middle. So it means that I am an instructor, that I am a teacher. So my wings have a book. So depending what you are, you have a different kind of wing. And then they call us Airborne Astronomy Ambassadors, or AAA. And then they have your name, you know, correctly written with my accents, because they tend to forget my accents. That's, you know, basic what, you know, you get, you know, the jacket, but I add a little bit of bling bling
glamour
everywhere.
Yeah, that's good.
This is the Orville sign to that. So it's like I put a stuff like Star Trek, Star Wars and stuff. I add a little bit.
Because you can.
Unofficial.
Because you can. It's your jacket. You can do what you want with it. So that's it.
Yeah, but when I'm on official business, I have to remove it.
Yeah.
But yeah,
there will be questions.
So then I can show you what I carry around, because the whole deal is like, if you are in a military base and you don't have your mission coin, you have to pay beer. I don't like beer. So I don't want to pay beer for anyone. So I carry around my mission coin. So that's Sophia. It's stuck. So nope, upside down. So that's Sophia, the mission coin, and here.
So what does it do for you? You just insert it into somewhere. You just show it like, well.
No, you just show it. So sometimes you can buy more than one, and you give as a gift for someone who you find like cool, or if you're doing something like to get money for some kind of project, and then you get them those coins, like, you know, a thank you note. Kind of cool, you know.
Yeah,
that one flown on Sophia.
Yeah, that's a cool coin for sure. A collector's piece probably as well.
So, and then you don't see this. I don't have this at all. Okay, it's unofficial that I have this. This is my badge that was supposed to have returned. I don't have it. You're not seeing that. Nobody's seeing that. Okay. And then what we did, we asked for everyone who was in a mission to sign it. I think you can barely see the signatures anymore. So that's, you know, the signatures of the people who were participating on. So I carry like a few cool things here. And then I went to the Space Academy. You know, it was fun with one of the other Sophia members who flown with me. So I'm keeping some, you know, the stuff in here, just, you know, to show.
You have some really big pockets in there. I mean, keeping all the stuff in. I mean, it's deep.
Yes,
pockets.
no, it is. It is a huge pocket. Has like a pen. So this is supposed for you to have it as you're, you know, doing presentations, or if you are, you know, zero, you know, microgravity. But this jacket has like a double face to keep you warm, because Sophia is very cold. Inside Sophia is really, really cold, because they remove basic almost everything. And then the equipment, you know, all the computers that are running keep Sophia a little bit warm. But Sophia is cold inside, and then they tell you to layer and use the jacket to keep you warm. It is very, very cold. So when they gave me this, they forgot I'm in Florida. And then like even the air conditioner start like I can feel the vapor coming off. So I use for pictures. When I'm done with the pictures, I have to remove it because it's too hot. So that's what I'm going to do right now. And I use like, you know, star dresses and stuff to make it pretty.
Of course. So look, I have. So Helen, if you don't mind, I have a question again to ask about, you know, about Sophia. And again, we're talking about the Boeing 747 SP model. So can you talk about what's the reason for picking this specific model of a Boeing?
Basically, they got a 747 SP. SP means special performance. So it means that a chubbier airplane is a little bit smaller. It's like, it's this one flown on Sophia, by the way. So it is not the long 747. This is a little bit chubbier. So what it means is that because it's lighter compared to the longer airplane, it can be on the air for longer. So it can fly in 10 hours with, you know, safety to come back home. So the missions are for 10 hours. And then you have to think about it, that even, you know, having a 17-ton telescope on the back, it still flies 10 hours with no problem. And then it's subsonic, so it moves very fast. It's almost 2 Mach, it's a 0.7 Mach, so it's very fast, even with 17-ton telescope. And it can fly, the missions are flown around 45,000 feet. So it's all the missions is about 40,000 feet, so it's about above 12 kilometers. So it's on the stratosphere. So an airplane like that, it's chosen because it can fly a long time, and it's very efficient. So it's a special performance, and it can carry a lot of load. That the case is the telescope. So you put it like around 20 to 22 people as crew. So that would be, the rest of the weight is for the equipment and the telescope. And even though it's lighter than a regular, you know, longer commercial airplane, because it's a special performance, and then they have like the Whitney Pratt or Pratt Whitney. No, Whitney Pratt air engines, so the jet engines. So it's like, it's the same airplane, but smaller. So that makes, you know, able. So this airplane specific, you have a few that are still flying, even though they're not manufactured anymore. And those airplanes are used for hauling cargo. And there's like overnight delivery of stuff, because it's a very fast airplane that can carry a lot of cargo. And you still have like rich people who own those airplanes, just because they're not flying supersonic, but almost there, and they can, you know, cross the pond very fast. So this is like still excellent airplane. And the other thing is the quality of the airplane allowed for them to actually make a garage door in the airplane, so you would be able to see, you know, not in the model, but in the picture behind you. So you can see that it's like one of the biggest garage door ever. So they open up, and then they change the shape of the airplane to make the airflow actually fly like above the cavity of the telescope, to avoid to be the biggest whistle in the world. Because they'll be like, you know, like even in the stratosphere where you have less pressure, by the speed that SOFIA moves, you would be the biggest whistle in the world. So instead to do that, they make like a shape of the outside of the airplane to move like a bump, so the airflow goes like above, and it doesn't touch the telescope. The telescope doesn't vibrate. When you're inside of the airplane, and the garage door, you know, the telescope door is open, you don't feel it. It's like you need to look at the graphics before the camera turns on for you to actually be sure if the telescope is open, because that is the pilots don't even feel it. The passengers don't feel it at all.
So the question, sorry for interrupting. So the question is, for the crew and for the pilots, once you reach the stratosphere, are you getting the oxygen through the tanks, or you have to wear masks, you know, oxygen mask at some point?
Okay, so the deal is that the telescope is in a cavity outside of the airplane. So we're not exposed to the stratospheric air pressures. So we are inside an air pressured cabin, even though the air pressure is a little bit slower. So when I see some of my videos they were doing inside the airplane, I was talking like this, and I did this, but I didn't even notice. I look at the videos and I found like I was doing this all the time. So in my head, it felt like I'm talking to you in my normally, you know, no, but I could see the video. So I know the pressure of the cabin is a little bit smaller, but it's just like a, you know, transatlantic airplane or something. It's just the same. Now, because this is an older airplane, the changing in the cabin pressure is very slowly, because it's controlled by a human, not a computer. So you don't even feel the thing in your ear, like you go, you know, you don't feel it, because one of the engineers are controlling the airflow, the air pressure, slowly. As he feels it, So you don't feel it. You don't feel the air pressure changing in the airplane.
Mm.
As landing is going up, you don't feel anything. You don't feel the door opening. So it's like it's smooth. Now, because we are in a stratosphere and we have to follow FAA norms, every one of us, we carry a little bit of it looks like a nice, women's purse that is green, like a crossbody, and then in there, you have you have like a bag that you put in your head that has an oxygen vial. So if something happened, the pressure drop, you have like 30 seconds or so of air for you to breathe. So you lose conscience. And then if an emergency is happening, you need to move away from the walking away to be away from the people who have the mission to kind of, figure out things. Yep. So me as an instructor, not actual part of the mission, but an observer of the mission, I have to learn not to be on the way of people who are working. So you are trained to not be on the way of people who are working. So in that case, we have the little bag. You have to pull it very fast. So we train to do that. And then you pull it ahead, you pull the valve, and you have the airflow coming. And that's enough for you to actually go to your seat, to sit down and actually pull the regular, masks that you have in an airplane and put on your face first. And then you learn, the whole deal that when you have like a training to be a flight attendant, we have a training like that. So we are trained to be a flight attendant. And then also by contingency, if the people who have the mission to fix things, it's unconscious, you actually are trained a little bit ahead to use the big oxygen masks that you can last a little bit longer, to move them to a safe place. If the airplane lands, you have, a special food that you can survive. You learn how to use the emergency radios. You know where the boats for safety are. You know how to open the doors, emergency doors, and put the slide that becomes a boat too. You know where the food is, where the management is, how to communicate in case you have a pilot disabled or, somebody on a crew disabled. We learn the minimum flight attendant emergency procedures. So that we do learn too. At first place, don't be on their way. And then just in case they are unconscious or something happened, then you're trained to do a little bit more of a step to actually, so you learn how to open the airplane door. You learn like few things. But that kind of airplane is chosen because it's a safe airplane. The changes were, easy. And you bought an airplane that was made when I born in the 70s. So you get an airplane that has a really good track in safety, maintenance, and is used, so it's cheap to buy and then change up the airplane. And then for you to see in an infrared, you have two choices. You make a ginormous garage door, or you put a diamond glass window. Because Congress didn't want to pay for the diamond glass window, they end up doing the ginormous garage door. So that's for the whole deal, how the airplane was chosen. It's used, good track and safety, and it was able to be changed. It has a long way to flight, so it keeps in the air for a long time. And other than that, you have also the airplane, being up for a long time for you to do your research. So that's basically choosing the airplane, and they train us how to use the airplane as like a minimum education as a flight attendant, and not to be on the way of other people.
Got it. So the question is it possible, again, but because this is a huge plane, and of course it does a lot of great research and things. So with the things that, things are getting reusable, smaller, people now looking at the reusable rockets, and instead of putting out there, satellites of the, 10 meter, 20 meter size, now we're launching CubeSats. So do you think that it could be that you know, we could use something, you know, smaller, just like a private jet. Let's say something like a Gulfstream 650 ER, something that will be kind of in a big range, but still would be smaller to do, you know, similar maybe type of research. Is NASA planning on these type of things, or are they going to still?
Yes, there's some, you know, people talking about some planning, but you have to think about that microwave is centimeter. Infrared is a little bit this millimeter and sub-millimeter, so it's a large wavelength compared to nanometers of the visible light. So for you to have definition of the pictures, you have details in what you're seeing. To get a better view, you need a larger telescope. So this SOFIA telescope is about a little bit bigger than the Hubble Space Telescope. If it's smaller than that, whatever you're taking picture in infrared, because it's a larger wavelength of light, it's not feasible for you to use a smaller telescope. But that is another way to do infrared, is that some people floating out the idea that after SOFIA is going to last for 20 years for now. The funding and the planning is for SOFIA to be 20 years. So already 6 years are done, because I was in the first my first flight was the last proof of concept, and my last flight was mission starting, you know, like counting the 20 years time of funding for SOFIA. So in that case, you have you know, that long time. So people are floating ideas that not do you know, a gigantic telescope, but make like a squadron of drones that can do you know, collecting together, doing you know, putting all the data of smaller telescopes putting together to get a larger image, just like you do in radio telescopes. So you instead to have one small telescope, you have an array of telescopes and you get better image. That's one of the ideas that is being floated after the SOFIA mission ends, to be compared to SOFIA. When you talk about CubeSats, if you can do array, it works, you know, doing interferometry, but it's kind of hard because, you know, they are lower. They still have some motion of the atmosphere, even though you know, it doesn't twinkle. And the advantage of that, because SOFIA, if you have a problem, land the airplane, fix it, and go again. If you want to change the camera, land the telescope, change the camera, and go again. So it's like the advantage of SOFIA, it lands every day. You know, it works at night, finish the mission. If you want to improve, if you want to change, you know, programming or hardware or kinds of camera or the wavelength, what kind of camera you're using, if you do spectroscopy or if you're doing imaging or you know, you measure just the quantity of light that's coming. So depending on what kind of research you're doing, you can do a specific camera to put on SOFIA to fly, and then you land and you change. When you put something that is a satellite, it's gonna die there, because we're not doing, you know, it's like smaller satellites, not worth for you to fly up and fix them. You just, hopefully people start thinking to deorbit those objects, or it's going to become, you know, space garbage. Yep. Now, so you have to think about it. If you launch to space, it's going to be the best, because that is clear sky. That is not atmosphere whatsoever to you know, dumping your data. But if you have a problem, boo-boo, you lose your mission. You know, during the launch, you can lose your mission. You worked for, let's say, 10 years as a student under a professor who was just, you know, planning the projects, not even constructed. So when you complete like the 20 years that you started university and you do your doctor degree, and you probably, you know, maybe you're no master, between master and doctor, you're, you know, second or a third in the command of the mission. Then you wait for the launch of the mission for you to finally get your data. And kaboom, you lose your data, you lose your career, you need to find another mission for you to be, or you're going to teach. because you lost, the chance. So the advantage of SOFIA is because you can change cameras, you can propose a camera as an institution in Germany or Europe or United States. You can actually make the camera you want to do with the wavelength, with the capacity that you want, and you do that proposal. It's going to take the same time for you to put a satellite, but that is no risk of kaboom during, launch, or even though after you launch, something happened on launch, you lose your spacecraft, or works a few days and you have some technical problem. And, like Hubble had it, that we need to put eyeglasses on Hubble like a few times. And so Hubble had a lot of maintenance. Yep. And the maintenance of the Hubble costs more than the Hubble. So it's like, there is no way for us to do that anymore, especially cutting funding of science. So that's my function, to keep funding of science, because I'm helping to raise the next generation to say, no, I want science. I want science because Helen told me to. No, because I explained to them that for them to have something like this in their pockets, it took 30 years of people dreaming with it. I explained to them that I have a rotary phone that you have to put your finger and turn like this to actually talk to your friend. And then when someone wants to talk to your house, your mother scream at you to leave the phone because she's waiting a call. So now it is in your pocket. And it's not just the phone that is in your pocket. The whole encyclopedia is in your pocket. All your friends are in your pocket. This was in Star Trek when I was a child. And now it's in my pocket. It's like unbelievable. So the deal is that I explained to them that for every dollar that you invest in science, doesn't matter what it is, if it's astronomy, physics, medicine, whatever it is, whatever $1 that you invest in science, $7 come back in return in the economy of that country. So that's the importance for you to do a mission that costs more than $1 billion, because what we are learning on SOFIA is going to end up in your pocket in 20 or 30 years. I promise you, because it's already happening. I saw it happening.
But it has to compound over time. It will not happen tomorrow, because people these days, they lack patience and they want to see instant results, which again, nothing that's been created great didn't happen overnight. So we just have to be patient. And of course, you're totally right. Like the technology that you showed us, the phone, the computer, the running shoes, and like the things that we take for granted, they came through the space exploration. And I say that all the time, just for people to be aware about that fact, so.
Yes, because they are native. For them, the world was always like that. Now, for me, who born a little bit earlier, I know that was not. It's like in my college, I use a computer that I have a floppy disk of this size, like bigger than my head. When I have like those 2 floppy disks, so I have to do one for the program, one for the data that I want to record. And it was, if I'm not mistaken, Fortran, because this was, 20 years ago or more, 30 years ago. So that's what I use, what kind of computer. And then we call it a computer Godzilla and Godzuki.
Very interesting. And I have a list of things, so I won't sound smart like I know this from the top of my head, but I just want to, mention a few things. So star birth and death, formation of new solar systems, identification of complex molecules in space, planets, comets, asteroids, nebulas, galaxies, celestial magnetical fields, black holes, at the center of the galaxies. So my question now is, which one is your favorite and why?
Okay, so I say that home is not just our planet, as the galaxy. So when I think about one of the pictures of SOFIA, and it was improved later that you just read in the list, is the center of the black hole. Mm-hmm. So that area was invisible to everyone in radio. It was only possible when we start doing astronomy in satellites or above the atmosphere, what blocks the infrared. So we could see invisible. And then as we could see the invisible and look at the center of our own galaxy, it helped us to prove that most of the galaxies have the central black hole. And when I look at Sagittarius A, I look at my black hole, because it's in my galaxy, it's in my home, so it's my home. So, and then a few months ago, they actually improved the picture because they use the dust, the orientation of the dust, to know the magnetic fields going into the black hole of one of the famous pictures. And they are actually doing that in our own home, in our own black hole, in my black hole. So they start doing that, and so this is amazing because it's something that is invisible, and now that's my favorite. So
we're talking the one that you mentioned. We're talking about M87, the one that's in the center of the galaxy, right?
Yes, that one. But Sophia has this extensive data on the one at Sagittarius A. That's your own black hole. So it's the black hole of our own galaxy. So that's my favorite, is that one.
Gotcha.
And getting the data of that, it not just took Sophia.
Yeah.
It took all the observatories that are available to put together all the data. So it's this amazing thing that it's like you can see the invisible, and it's not just your mission, but everybody else putting the data together. And that's how science works. That's how now I can wear no mask, because science work together. Yeah. If instead like everybody like putting copyright and blocking everybody else, or buying companies to take the control of the patents and nothing happens. No, when we work together, we get cure. When we work together, we understand our own home. Yeah. It's like that's what it makes the wonder of knowing science, the wonder of putting a telescope in an airplane. Okay, so you start like this. Airplanes are cool, right? Cool. Telescope are cool, right? Now you put cool telescope inside of cool airplane, you make double cool. Now you put pilots are cool, right? But when you have pilots, there were also pilots on the space shuttles. You have astronauts piloting Sophia. So it's like you put astronauts, astronomy, telescopes, and airplane, and all in one little thing. And then you take a picture of the center of a black hole, stuff that it was invisible for decades, and now it's visible to you. It's so awesome.
It is definitely awesome. Yeah, so I see you get you excited talking about this topic. So because it's really fascinating. It's really fascinating. Black holes is one of the big topics, and again, I know there's only less
3 years old, like miss, explain black holes. That's their favorite.
Yeah. So again, and I think that's really important that you just said, just for the people who didn't catch that through the collaborations between scientists, just regular people, maybe who have telescopes or are involved in a certain projects, through those people, the science and the future of the humankind will continue to move forward. And I think that's why it's important that you continue to spread the awareness, just like this today, by being on a podcast.
Spreading the gospel.
Exactly. So we need that. We need that because there are billions of people globally who still don't know where we are positioned in the galaxy. Some people still think we're, flat
Earth,
or we, the turtle and the elephant is holding the Earth, whatever.
That one makes even more sense than the flat Earth.
Yeah, I think so.
And then what is fun is this people using the technology that disproves them, for them to, like for this to work, you need a satellite. Satellite needs to orbit. Yeah. Orbit is a sphere. Yeah. So it's like, without the science that disproves you, you cannot say what you're saying.
Exactly. Look, because I think, that's again the power of the social media, and we have to be very careful the way we spread the message out, the gospel which you're talking about, because there's a lot of people who are, they're not singing the right songs to the audience, and people get, misinformed, and there's a lot of that happening. Because people are doing it for the likes, for the follows, and whatever they measure success. And you do for, science reasons, and you want people to get the right data. Fun. Exactly.
It's because it's fun. It's fun. When you're behind a telescope, you're looking at the telescope, and then you're teaching a child to look at the telescope. They go and look. I don't see anything. You can see their face. They are not seeing anything. Then, because they have their peers around you, oh, I see it, but the face doesn't change. And then I go, hold a minute. Now I'm going to teach you to look at the telescope, especially if you're looking at a telescope, an eyepiece for the first time. You don't know where to put the, to put the center of your eyeballs in the center of the eyepiece so you don't see well, especially if it's a high magnification eyepiece. So I teach them how to use it. And then you see their face change. It blooms like a flower. You go like, Saturn! You can actually see, I'm outside, like looking at the eyepiece and their faces like this, and I can see the change. That's something that is totally addictive. Yeah. You see, a child sees the planet of Saturn for the first time. They are having their life of their times, but I am every minute having that every day, every time that I see a child, paying attention. When I go and explain how stars come about, I explain the life of the star, how it recycles, where the chemistry of it, and they go and I see them like looking at me, they don't even blink. That is so cool because you're actually teaching, and they are paying attention and they are finding that beautiful and they are finding that like poetry in science. So that's what keeps me doing it. It's like most of the stuff that I do, I don't get paid for. But, of course, I have some stuff that I do in science, like teaching that, pay the bills. Yeah. But, most of the stuff that I do because it's my own fun, like, when I was younger, I kept going nightclubs and holding necks and heads and toilets for them to, call Hugh or, Raul. So that I got tired of that. Now, Saturday, I go instead to be holding people in toilets, I'm holding people to look at the stars, just like, and that's my fun. And when you go to places like nightclubs, you meet people that are empty or you don't have time to actually know them. When you know someone is coming to a museum, to an observatory, to a planetarium, you know that people have that same interest. And then you end up meeting up people like you, like some of my friends who actually can understand what I'm saying. Because I have some other friends that they go like, please don't geek out, please don't geek out. And it's like, it's my nature. I am a polymath, it's like, it's the way I am. And so it's like, it's good because you make connections, you make friendship, and you feel. And the other thing that gives, I've been in the Army, and then that feeling that you have, that you're not just doing that for yourself, you're doing that for your colleague and for your country. You have a mission, you have a flag, you're behind it. So that's like, so for me, I miss to have a mission. So my mission is to bring knowledge to the next generation so I have a good retirement. Okay, it's not that pure. But if I have people educated, they're gonna put people in power that gonna decide my life in a manner that it's according to the way I think. So what I'm doing is that teaching people, bringing science to people, and not just science specific, but for them to actually looking at the data and not to believe everything that people say to you or you see on Facebook. Oh, right, it's a good fount of information, Facebook, right? So you have, what I'm teaching is people to analyze what they have in front of them. Doesn't matter if it's astronomy, physics, medicine, whatever it is, read the data, find a specialist. The guy on the internet that has no degrees, no specialist. You need to find people who actually, at least have a master's degree in something to actually believe what they are saying, or at least ask the data for you to read yourself. Of course, not everything you can understand. You need the specialist to give the opinion where it comes from.
So, but the question is,
a function of you, a function of me, is to do that. Talk with the scientist, listen to the gobbledygook, and translate in a manner that you allow other people to verify the data, look for other specialists to do. So it's like, it's function of the future of this planet.
Yeah. So the question is that I wanted to ask you again, and that everyday people, it's not the people who are the scientists who have the master, triple master degrees, the PhDs. Those people, of course, they're doing a lot of research and they have, the data, the science to back it up. But I met so many different people, let's say, who do variable star observations. They're regular, day people, they have jobs, but they have, through the time, they, saved up a little bit, they build their own home observatories, they have, 22-inch telescopes, and at night they become those astronomers. And the amount of work that they produce to the science and the amount of value that he adds. So I wouldn't discourage anybody who's listening or watching that if you don't have the PhDs or the science degrees that we're talking about, that you shouldn't be doing science, because there's different aspects of
Citizen
space.
Science is very important.
Yeah. So there's different entry points in the space industry. I mean, you can be a space doctor, lawyer,
Sure.
architect. It just depends. And I see so
Pharmacist.
many people. Pharmacist. Yeah.
Yep.
How's that gonna
So
look
that's
like?
why I did chemistry, because I my degree. So when I went to college, university in my country, I was kind of trying to decide. I started mechanical engineering because I like engineering awesome things like the stuff on the back of you, like aeronautical engineer. I had a dream to be an astronaut, so that was my interest. But then I discovered that I cannot hold my cookies. So because of that discovery, I'm like, forget about, you cannot be an astronaut again. So I was trying to find, like, I like science. I like, the more I can study, give me all the science. So I look at the curriculum of my university, and they have pharmacy and they have geology that has the most, stuff, like diverse stuff, not just, so pharmacy, you could have botanics, any kind of science, biology, and then chemistry, like it's a whole 2 years of pure chemistry. And then you have, the area of medicine and, pharmacology and organs and anatomy, and you have all that. So, oh, this is cool. And they even have physics and chemistry and, math. That's my weak spot. And then they had geology that had all of that too, but it was a little bit weaker in chemistry. And then when I was in mechanical engineering, my lab teacher told me I should do something in chemistry. So I thought about it. Maybe, geology a little bit weaker in chemistry than pharmacy, so I'm going to do pharmacy. And then maybe later I do geology too. So it's like, I was like that, because, the dream of astronomy, the dream of science, I was never that good in astronomy or in physics and math. My problem was the math. I understood the physics. I have, I can understand the, the stuff, but it's hard for me when you calculate that. I'm like, no. So when I went and decided to do pharmacies was mostly because of the chemistry, but astronomy is pure chemistry. And so when I came to the United States, I need to find some, because I came as a officer for a consulate, because I'm multilingual too. So I was working in diplomacy instead to be working pharmacy or science. And it was killing me. I need to use my brain, because I was just, a desk jockey, just stamp paper, looking at documentation. I was bored out of my skull. I know I was going to get mentally sick if I didn't use the science knowledge. And then during the year of astronomy, 2008, when 400 years of astronomy for Galileo Galilei, I don't know if you remember that. You're probably too young for that. So it was when I start at Fox Observatory, because, oh, people who understand what I'm saying, oh, people who like that, people who understand, it's like, oh, I found where. And then I start just as a member, and then the instructor moved to California, and then I'm like, oh, I can instruct that. And then I became an astronomer by accident, because I was bored with my work. And that, being an amateur astronomer, lead me to missions in NASA. Can you believe that? I cannot believe that till today. It's like, so even if, like, I tell the trainees that I train at Fox Observatory, even if you're becoming a lawyer, or you're becoming whatever it is, like a administrator, something that has nothing to do with science, you can still do science. You can be an amateur in any kind of science you like. Like geology, go look for rocks. By the way, I have lots of rocks. I carry one in my neck.
What is that? Is that a specific?
A meteorite.
Oh, is it?
Yeah.
Where is it from?
And this is the one that fall in Primorsk region of Russia in 1960s.
1960. Okay,
Is
so
the Shala something.
that is really
Yes,
awesome.
this is like 1960s.
Does it give anything that does it changes your mood? I mean, does it do any effect?
No. It's just for me I am data-driven person. So
Yeah.
this is like when you're showing rocks, when you're explaining the age of the Earth, people say, how do you know that? How is that true? Why Earth is not so just 6,000 years? How can you prove that Earth is actually 4.6 billion years old? There you go. I carry my neck. And then I explain how they get there. I have Geiger. I am a kind of chick that has in her purse a Geiger counter. So I carry around an infrared camera in my purse. This is an infrared camera. So you put that on your phone in the dongle, like you connect with the phone is like a USB. So I put another dongle to put because my new phone is a C. So this I carry and I take infrared pictures. Just advice to you that if you have trainees, don't leave your camera in their hands because they're gonna take butt prints pictures everywhere. Like if you sit down and you stand up, they're gonna butt print. When I look at my phone one time, like, okay, it's like butt prints galore. They love butt prints because it's an infrared astronomy, and then I got an infrared camera. So what I'm telling you is that doesn't matter where you're gonna, put food in your plate. Doesn't matter. You can still do citizen science. You can do your own science. So right now, Broward Astronomy and some other people doing together, they are gonna try to do what John Dobson made for the astronomy. You know who's John Dobson? Is the inventor of the Dobsonian telescope.
Yeah.
So he was a monk. Tell me something that has nothing to do with astronomy. He was a monk, and then he found a way to, grind the mirror the glass, and put in a simple box that could move around in a, dolly and go up and down. So you have out and azimuth. So what he made for astronomy is to make some instrument that was extremely expensive that no one could have to something that everyone has in their house when they get like 10 years old. Dad, can I have one telescope? So what they are trying to do is make a simple arrays for radio astronomy and connect via internet. So do array, like, you can make the whole planet the size of a telescope. You can get very, big wavelength, like radio waves, and get imaging. And that data is going to be available for the scientists. Same thing you have for people who accompany you, probably are familiar with Zoo, the Zoo website. So you have Astronomy Zoo, Galaxy Zoo, Ocean Zoo. So they get the data. And then because our eyes and our brain are way much more complex than, algorithms in computer, they ask you to train the computer. So you get like, 5 million people participate in the Galaxy Zoo to classify the galaxies. I don't have an answer for that. And then I have to turn off my computer. Okay. Right. Okay. So I quiet down my Alexa because whenever I say the C word, she activates. So now it ain't gonna happen anymore. So whenever you have people trained to do that, you train the algorithm and then you make science easy. The data, and they're like, you have children discovering novas because they are looking old pictures, and then if you discover it, you can name it with whatever name you choose, your name, your mother's name, or weird name. So it's like, it is awesome that because of the internet, even though we are getting too distracted, that is the criticism of, being connected all the time. But then that is the other side, that this can make you get and to discover something using the data that is available now. Many telescopes there are defunct, but there is not enough eyeballs to actually look at the data So they go and train you to read the data, and you can do your own discovery. You can do your own science. And it doesn't matter if it's in astronomy, you can do in biology, you can do in geology, you can do in any kind of science. And so it's like, that's possible to be a scientist, even though it has nothing to do. My formation is pharmacy. I end up working as in diplomacy that has nothing to do with that. And what saved my sanity is being able to use my knowledge in science, not just to use it doing science in a tiny little observatory, but also get a new generation of 10 years of, actually 12 years working on that. I have a bunch of kids who I trained. They're already in college. Some of them are pilots. I have a good quantity of pilots that pass through the observatory. I have people who are doing communication, doing physics. Then there are people who are just finishing, bachelor degree and start master degree in physics. I have odontologists. So it's like, that is like so doesn't matter what you choose, you can still be an astronomer. And maybe if you're lucky enough like me, that was big luck. That was big luck, because I realized my dream to be not actually an astronaut, but an aeronaut. I went to the stratosphere. Yeah. I have my astronaut jacket, and I'm simple clerk and teacher. It's like, I got it. So everyone can do it. It's just you find the right institution and you learn enough and you teach. And it's like actually a good thing that I did my whole career of college. Whenever I learn more is when I teach. So whenever I was teaching someone, I learned more about that. So I learned more teaching, not just astronomy. When I was doing chemistry, physics, whatever it was, when I have my group of friends, when they were teaching me, helping me, I didn't acquire much. I just memorized for the test. But when I was teaching them, I need to have enough knowledge to answer a few questions. And some of those questions gave me more knowledge for me to research, to discover that. And then in the case of the observatory, I'm still learning, because sometimes you get like a 3 years old, Miss, what is that? And you go like, I don't know, but let's research. And then I learn more. You have like kids that you go and look, how old are you again? With amazing questions. That brain is
they're
like
curious.
sucking.
They're curious. Yeah.
Yes. And you can see that brain is a sponge of knowledge, and you just want to feed it.
Yeah. So the question is that I ask a lot of people as we're talking about, we have the data, again, looking from the arrays or the, observatories globally, but we don't have enough eyeballs, looking at the data. Of course, we have AI technology that, and we have the algorithms that try and help us to run the data, and maybe we can find something through that, but we still need people. So now the question is, you as the science communicator, what do you think will be the right approach, again, through your personal experience, to reach more people? I mean, using and leveraging social media, doing more outreach, like what will be kind of the easiest way? Because it feels like now we have a lot of momentum gains, and I think COVID helped us a lot with the, you see ads right now about, related to space and things like that. So a lot of t-shirts floating around, again, by NASA and other agencies, but it's great. So how we can continue to build that momentum? Which way would you communicate the science?
So if you asked me that question like 2 years ago, I would tell you it's like in the observatory talking with kids. But now I have a new platform that I didn't know how to use it, because I am not like you, native of technology. I learned forcefully, and I'm still, you notice that I took some time to find the link again, so you understand that, because of I am not native. I was forced to learn it. So then now that's the new stuff, that you can communicate with someone in another continent, like we are doing right now. You're in Canada right now, right?
No. We're traveling. I'm actually from Ireland, but we're traveling in wife's country in Georgia. It's in Europe.
Oh, okay. So you're in Europe. Yeah. So I'm also Portuguese. So I didn't have enough space for the flag, but because I born in Brazil,
Got you. Yeah, same.
So we are talking in another continent, across the huge ocean that took 3 months to cross. My grandma took 3 months to cross the Atlantic from Portugal to Brazil during the war. And now we're talking right now at this moment, like you're, sitting on my table. Yeah, so this is the new platform for you to actually go and do the communication of science. And not because I work in science, not because of that, it's because I want the next generation, especially the generation that's gonna put me in my retirement home.
Yep.
That generation is gonna decide my life in a few years. So I want that generation to have critical intelligence, to know and try to at least ask, is that BS or is that the truth? Should I believe in this, or should I research a little bit more before I give my inflamed opinion against or in favor? No. And then, everything, the magical thinking is for babies. Adults cannot have magical thinking. You need to analyze the data and take your decisions every day. When you cross the street, when you get to your car, when you go and buy something to put in your mouth. And then the diffusion of science is important to create a generation that's going to read the ingredients, what they are eating. The generation that's going to listen something on Facebook or even on TV and ask, wait a minute, this is too inflamed. Why not speaking in a calm voice and explain that? Why are you screaming? So what you're saying might not be truth. So go and research, have the question mark. Like one of the things that I teach the kids, but I say I'm sorry to the parents, like you're the parents. I'm so sorry what I'm going to say to your kid right now. And then I turn to the kid, question everything. Question everything. That's what I want to actually teach. And that's the new platform of what you're doing, what I'm beginning to do in the way that I am learning. So maybe, I can maybe one day fund something and retire from teaching and, being online and, being an influencer. But right now, it's like, that's important because that's the people who are voting. That's the people who are going to, decide the future. Not specific in science, but if you have that critical thought, if you question things before you believe and you put your flag and you scream, we make a better planet for everyone. Everyone.
So what you're saying is so true. Is as the quote follows, but you said that you're not a big fan of a math, but the quote says that the best math that we can learn is how to calculate our future cost, the future cost of our current decisions. So, and that's what it is, as you're talking about life is being, every day we'll make decisions, and a lot of those decisions, of course, we'll make unconscious, because this brain, this muscle that we're carrying here is actually quite good at protecting our, this meat carcass that we're carrying around. You can make a lot of decisions automatically. We don't have to think about a lot when we're crossing the street, and of course we have to look, but that's kind of done unconsciously, most of the time. But I think,
we don't have like actually to write an algorithm to cross a street. It's so much more complex than you teach a child 3 years old, look one side, look at the other, and cross. Like, it's so easy to teach a child to do that, and it is write that algorithm. It's very big, and so it's amazing computer that we carry around. We just need to use your platform, my platform, now online platform that's new for me, because I'm used to play with slinks and Play-Doh and actually teach kids to do cool stuff. That's what I do. I translate the gobbledygook and stuff that they can touch. And your platform is teaching me to, maybe I need to change a little bit because I can reach more people.
For sure. Look, everybody can. The question that I wanted to ask you is, as I'm, telling you that quote about making decisions and, asking questions, as you're talking about that as well, like, what do you think? Because asking the right questions, not looking for the right answers, because how, first of all, framing the question in the right way so you can get the right answer. So the questions are more powerful than the answers that you get if you're asking the right questions. So what do you think as the science communicator, again, still, space industry being very diversified, space engineering, medicine, law, there's a lot of different sectors inside the industry. Like, what do you think, what type of questions we should be asking as people to make sure that we can have those, scenarios as we look at the, Star Trek movies and things like that, so we can bring future closer to reality?
Okay, so things that we need first for survival. So when you frame, like you say, like Newton taught us, you have to frame your problem to actually have a resolution, because it's in relation to something. Everything that we know, everything that we learn is in relation to something. It's always using what you know to get to the next step of the next question, because you cannot make a question if you have no knowledge of anything. So you need to start with the simple question that you know every day. So I think when you frame as in survival, because we're at that point, unfortunately, I think that we start seeing things. So when you go and you defund telescopes that can see in an infrared in space, or SOFIA, you could have a surprise asteroid that's going to kaboom, not the planet, but it could kill a whole city. We have, like, planet-wide, probably it's way much smaller, but city killers are everywhere, and we haven't mapped all of them. So when you do that, you frame in survival, you frame the question of where the next funding go for the next science project, for the next enterprise in science, that is probably going to get an awesome, bolometer that you can put on your phone and you can carry around as an infrared camera. This wasn't a space telescope, and now it's in my hand and I can put in my phone. So that's what it comes about. So that is the investment for you to survive. And then the answer is jobs. So when you frame survival and jobs, people hear you. I think that's the way. I don't know. It's because I live in Florida. Florida is a state in United States that has a very conservative politicians. And there is a lot of domination in some of these powerful industries, like the oil industries and all the industries too, that bring jobs. So when you frame your problem, you need to actually explain that more jobs, they're cleaner, that's better for your life, that better. So it's like, Florida is always sunny. Why not, instead to have oil extraction, have wind and solar that we have a lot in here? So that's how you frame it. You frame, like you said, the cost, how much it's going to cost. What is more expensive? Mitigation for climate change, or avoid climate change and bring jobs in better industries for the people? So it's like, you need to frame correctly, and then scientists are going to find a way to find the research to do that they will always do. But you need the citizen, the engineer, the mommy, who see that, wait a minute, I can use that in another manner. So this 20 years ago was in a lab research, and today it's in my hand, but a decade ago it was in the hands of firefighters, doctors, engineers, looking for fire, looking for leakage, looking for electrical problems. So this became a science. It started as a pure science. It became a product to be used in industries, and now it's fun because I'm taking butt prints in infrared. So this is like, it's a cycle that comes from the lab that people will never use that. When Faraday was playing around with electricity, this is useless. And then, ta-da, look at it. Everything is like, in me and you, it's like everything is connected to electricity. So, yeah. So, in my opinion, when you frame the problem in survival and jobs, people hear you.
I do try to believe that, because I think that's a really great principle. And actually, I just wrote that, principle for myself here on a page, because I think that's a right, way to look at things and, plan future projects, put projects together from this perspective, survival equals jobs. So that's really great. But, even though in this time, so I'm still thinking about, it sounds great on paper, how we can possibly accomplish this, because regardless, because there's always those people who doctors say, look, you've been smoker for 20, 30 years and now you have cancer, and these people, okay, so that's kind of bad news, and they continue to smoke. So, and there's a lot of those people who, have, not that, awful type of situations, but just like, okay, the meteorite is going to come over, we need to do something about it. Okay, so that's going to be the end of it. So my question is, how many people are like that, and how we can bring those people that actually want to be part of the change or create the change, to find the next Carl Sagans, or those people that would be in a science, and
me
exactly people like you, because we need those people, we need to find them, but those people are not aware about that, what's happening in the space industry. So it's very interesting, subject, and hopefully, through that lens, or through, again, social media, part of that, having those conversations with people like yourself. So can you talk about like the projects that you're going to be putting together, and continue to communicate the science, like how those projects look like, and what is the most effective that gather the most groups?
So right now, at this moment, we are without any specific projects, because we are just coming about of the pandemic, and the observatory is still closed to the public, because you're actually putting your eyeballs, you're breathing close to the eyepiece, and the next person is going to do exactly the same. So that's like, when we finally have like a great part of the population actually vaccinated, and when the vaccines are open for children, because our huge public is actually younger people who cannot be vaccinated, then we might be able to open the observatory. But right now, at this moment, what we are doing is Zoom sessions. They're remedial for what we are doing, and then scouting, ESA, NASA, Southern Observatory, CAPS, all the places where you have outreach information. And I'm grabbing that and then making a little comment for people who follow me to actually learn. So I continue to do the same. So that's like a remedial action for what you're doing. So your platform, you have a specific mission that you're used to do that. In my case, that's, for me, it's a learning process. So people like you are actually teaching me how to do those things. So for me, being online, being the internet, being video is still like really weird. So when you finally post this and put this to play, when I hear my voice, it gets me like cringing, because it sounds so up in the volume, and the tone is so high. I cannot hear my voice, and look at me. So it's like, gives me like the heebie-jeebies. So I'm not used to that kind of platform. But what I'm using is like to be sitting down on the floor with a bunch of kids, and they are talking all together, and they coming all together to hug me and clean their noses in my clothing when they get like, I have that a lot. So it's like, I cannot be in public like I used to be anymore. So I actually brought here like a few props that I normally do. So in the case of infrared astronomy, so it's not the projects, because we have no project so far. I have no idea. And if you have any kind of idea for me, I'm all ears, because I'm learning to use this platform. That's new for me.
I have a lot of ideas. I just finished a conversation actually with a group of people with a local astronomy club, and some people who are part of the Mars Society, president of Mars Society here in this country. And we're going to be meeting with those people sometime next week. And again, as I said, a lot of people, including myself, because I talk like it's 100-second episodes, which again, awesome. I don't take this for, I have another podcast which has 170 podcast episodes. For me, it's not about that. It's not about it's about having these conversations, meeting all these great people like yourself. And that's where you capture all these great ideas. If you keep it on paper, don't keep it here, because short pencil is always better than a long memory, right? So if you keep everything in written, that's where you get ideas. So, you know, but the question is, who's going to execute? Who's going to execute the idea? So, yeah, that's what it is.
Yes, yeah. Well, if it's something that it needs, you know, Play-Doh and slinkies and me talking, you can count on me to do that because I
Awesome.
have a lot of fun
You're
with
in-
this.
you're-
That's
you're-
my fun.
You're in the list. Okay, gotcha.
Yes, that's my fun. I can do that online. I actually did some presentations like from other people who are doing that kind of platform. Actually show Sophia, explain what I do. So I'm holding a slinky here. With this link, I can explain how the speed of light is finite using a link. I can show like the wavelengths as, you know, the slinky, you know, gets like this. So this would be like X-ray and this would be radio because those ones are close together. So I can use like silly stuff to explain something that's very complex that is hard to visualize. So I can do that kind of representation.
That's the true mastery. That's the true mastery. I heard that people saying, you know, a lot of times when it's something that's that complex as the speed of light, and when you can explain that to the 5-year-old in a simple terms, that's the true mastery. So
you can explain to everyone.
Yeah,
so
exactly.
That's what I aim. I aim to explain to someone that is, you know, 5 years old. If I can explain something to that child, their parents are understanding too.
Yeah.
So that you need to have the scientific knowledge, the peer review, established scientific knowledge that you're gonna adapt, you know, props that can be touched, can be seen, can be played with to make like it is easy for you to understand. So one of my presentations about infrared, before I bring the infrared camera, I actually use a remote control and I tell them to do the same thing everywhere. So if you see, this is like a simple remote control. If I use this, you cannot see the blinking of the light because it's not visible because invisible light. So I started like this. Oh, do you like to see invisible light? And then all the kids go like, yeah. It's invisible. You can't see it. They go like, But would you like to see invisible light? They go, yeah, it's invisible. And then I ask, you know, in the public, I play around a little bit. I tease them a little bit. And then I ask for the parents who have like Android telephones. And then I go to them and then ask you if you have, oops, wrong place for the camera. Okay, so if they have like, let's see if I can do this. No, I'm showing the wrong thing. Okay, so if you use the mobile phone, let's see if it's visible. Oh, I'm doing it all wrong. Hold on. I'm gonna flip the camera. And now I'm gonna do this. And then I'm gonna try to show this in here. Okay. Am I showing the camera? Did I flip correctly?
Well, it's showing the screen there.
Oh yeah, I flipped. I did wrong. Okay, so this is. Oh, I'm showing myself. That's weird. Okay. So now you can kind of.
Okay. Yeah.
See the blinking.
Yeah.
So I use the simple remote control that I have. I actually bought this in like a $1 remote control just for that. And I show them and ask them if they have Android phones, because Android phones don't have infrared filter. So you can actually show when you use the remote control and like, so you're seeing invisible light. So it's like I make them to see it. And then I have another one that I connect a solar panel to speaker. And then when I do that, you can actually hear the sound of this. So I just translated one kind of electromagnetic information into another kind of electromagnetic information that you can see in your eyes. I changed the wavelength. So now the phone, the CCD chip, or this case is a CMOS, is translating the data of the infrared in a purplish color that you can see. Now, when I do that in sound, I'm transforming electromagnetic waves in mechanical waves that you can see the sound, you can hear the sound. So when you explain like that, using props, give to them for them to play, they actually understand that most of nature is invisible to us if we don't have instruments. If you think about like the whole extension of this linking being the wavelength that we can see with our own eyes, about a meter size, only one circle of this linking is visible light. Our species is blind to the universe. We can only see a very tiny fraction. Yep. And then they go like, oh. So they finally understand. And then that expression that you say when somebody tells you something, in science especially, that makes no sense. Of course, it doesn't make no sense. Your senses are too limited. You have a very small wavelength in sound for you to hear it, because it will be infrasound or ultrasound. Visible light is only a tiny little fraction of the whole spectrum of light that can be visible. And our senses is fallible. You know, depending where you're touching, you can barely feel temperature. Actually, you don't feel temperature. You feel differential of temperature. So you see it's a heat, not temperature. And people like, what you're saying? Temperature is not same as heat? So it's like, you get the complex science and you explain that you need instruments to actually observe nature because your senses are too limited. We did that like maybe 300 years ago, but we're done with all the science and now everything is instrumental. And that's what's becoming even cooler, is that now you have those instruments in your phone. And then it used to say, now science has become big science, you know, more than $1 billion instrument that you're using, that in the picture behind you is more than $1 billion instrument. And now we are going back to a small science, because you can have those instruments in your pocket. So we are coming back in another way. So sometimes now people are putting microscopes in your phone, so you can actually have doctors in the middle of nowhere using their phones to figure out you know, disease in the blood of people. So it's like, it was giant science, it was small science that you did in your garage, like Dalton discover, you know, the atoms. And then you go back to big science when you have ginormous telescope that take a top of a mountain. And now you're going back again to small science, because those big instruments are miniaturized and in your pocket. So yeah, we can do science. We can find a way to do science.
But I love what you're saying, that, you know, questioning things, always questioning things, and
question everything. I think it was Carl Sagan who said that. I'm not sure.
And Carl Sagan, and I know Richard Feynman, who was a
I love him.
He was a famous, you know, physicist, and he has many different YouTube videos. And of course he's long gone, but you can go, guys and girls, find those videos online on YouTube, because that content lives forever. And you can see him questioning and talking about why does the water boil? You know, what's happening in that process? How does the heat works? And when you drop you know, water on the glass, and how does it stay in one place? So he's very like, and he said, you know, I love to sit. It's fun to sit down and question everything. Why?
By the way, read his book. You're surely joking, Mr. Feynman. That's the name of one of his books.
Famous,
that is hilarious. I was on the airplane reading the book, and I was like, you know, laughing, and people looking at me like, yeah. So he's hilarious. He's hilarious. And he exploded things in his garage when he was young. So it's like,
and
I'm
he
not
was
too different.
And he was part of the research with the, you know, with the spatial disaster that happened. I think it was one of these, I can't remember which one, but he was doing, you know, research and finding that there was this ring where the boosters were, and that it got expanded, and of course it you know, and contracted, it got expanded because of the cold and heat, you know, and you know, was part of the cause. So, you know, he was involved in a lot of different great projects, but yes, you know, and he inspired a lot of great people who are probably doing, you know, science right now, you know, and part of the people just like you, and as I said, you know, about the ideas, putting ideas together, I would love to have you on.
I am here because of Carl Sagan.
Here you go.
I am here because of Carl Sagan.
And now we have to find another Carl Sagan, right?
Yes, maybe me. No,
Search.
Neil deGrasse Tyson is pretty good. Neil
He
deGrasse
is
Tyson is
good.
pretty good.
He's
And
good.
he simplified even more the science, because when you look at Cosmo from Carl Sagan, when you see the videos, he's more scientific. Neil
Mhm.
deGrasse Tyson popularized even more, using even more accessible language.
He's on
And he's
TikTok.
a really funny guy. And I like, kids love him because he's
Yeah.
funny. And like, Carl Sagan was more like zen and more like adult kind of
Mhm.
thing, even though I was a child when I saw Cosmo for the first time.
Yeah.
But Neil deGrasse Tyson's kind of, the fun kid who, bugs the teacher. That's the
That's
kind
the
of,
answer. That's the answer,
yeah.
because like Helen, I do believe that's the right way to go about things, because I just as I talk about this, having conversation with this group of people just yesterday, and they told me exactly the same. They were looking to put a project together, and they talk about quantum physics. Big topic. Again, for the audience who are completely green, they don't know what quantum physics is. And when you drop in a professor from a university, and from the first like time of opening his mouth or her mouth, they start to give formulas and like diving deep into the topic.
And then
like you're gonna
"Ugh."
lose people. And that's what they
Yes.
said. The audience was lost, and people were like, I didn't expect that. It's a shocker. Like, oh, I don't want that. But when you give this information to the people in a fun, engaging way, people, because for the people who are not aware, and that's I think where a lot of people say no to the science and no to astronomy and no to different things, because it's too boring. Like, people
Yes.
can, once you understand, like, give them the terms, understand, like, let them know this is fun and
The
you can enjoy
lectures
it.
are for people like us,
Yeah.
not for the general public.
You can always sit at home and immerse yourself and learn, and that's homework.
But if you're doing outreach, it needs to be fun. It needs not to put people to sleep.
Yeah.
Even though I put Boy Scouts to sleep sometimes.
That happens.
The Boy Scout training. So it's like, when I go, I have this, like, this is the props that they gave to me. This is astronaut food. I don't know if you're going to be able to see. It's like pudding. This is like, has calories for 3 days. You have like a shortcake that's very concentrated. You can be a week eating that to survive like in nowhere. That's the stuff that I gave to me on SOFIA, that I could show that we're doing a mission. This is the preparation they give to us to do. So you use the stuff to show, oh, this is astronaut food. Let me see. So you can actually see Zoe like squeezed, because I have lots of Boy Scouts actually squeezing it. So, and then when you come to a place and you be presented, especially when I'm doing a comet, my comet is legendary. Like, some of my trainees are find it, oh, it's legendary. I was like, yeah, my comments is legendary. So we do like videos and show, and the kids filming, and I let them hold the comet after I finish. And then when I come to the place, I ask them very seriously, like I'm a scientist, doing, and I have like a white coat and very serious, and they introduce me with pomp and circumstance, not knowing that I'm not serious. And then I go like, would you like to do an experiment? They go, yay! Or would you like to do a messy experiment? They go like, yay! The choice between an experiment and a messy experiment, of course they're going to show the messy experiment. So I explode comets. When I do craters on the moon, I use a chocolate powder on the top of a white flour. And then you throw like balls on it or stones, and makes like a jet of the moon. So perfect that you swear you're looking at the crater in the moon. And when we do that, it's flour everywhere. It is a huge mess, but they love it. Yeah. But for me, I have two pleasures: to see them very happy, like a little pig in the mud, like having their fun. And then I even have more fun when I look at the parents and they go like, I love to freak out the parents even more than the kids. It is so much fun. Yeah. Or when I am explaining about supernovas and I see them talking parallel, I start lowering the volume, and then I scream supernova, and I scare them, like, I put it the supernova to explode, and I love to do that. I love to do the supernova, awesome. and scream a supernova, and I get the trainees around me to have in their phones the noise from an explosion, and I ask them to scream together with me, supernova. They know when it's going to happen. So the kids go like this and then start laughing. So I love to freak out kids. So when you freak out them, when you let them make a mess, when you let them actually touch things, you learn. And if we do with the kids, give, like in my case, 12 years, I have a bunch of kids who are already in college and doing that. You know, the one that I mentioned, Matt, that is in odontology, he finished odontology, and I tell him that he needs 2 years of profession to actually apply to be an astronaut. And I told him he's going to be, you know, rejected a few years, but keep going. So I'm trying to convince some of the kids who worked with me when they were in high school to actually, you know, try out to be an astronaut. And I have Lee Giat that I mentioned to you. He actually did a course in the Star City in Russia. He actually trained to be an astronaut. So I have kids already going there because when they arrive there, they have like stuff to touch and feel, and someone who's going to ask, they can ask anybody any question. And I will never say that, oh, that is a stupid question. That is no stupid question.
So can I ask you a stupid question?
Sure.
Can I ask you a stupid question? And of course, that's, you know, that's the question that I wanted to ask, because I think that's really powerful of just using my own personal example. As you said, you know, every young kid who grows up, regardless the gender, you know, age, you can be from 5 to 3. Once you start talking, questioning kids, what do you want to be? Astronaut is going to be there, right? The thing is, when people,
footballer and model,
could be. So I never said that, but astronaut probably was their fireman or a doctor or anything like that. But you know, people lose it, including myself. People lose it because you have the life hits you. There's certain
you need to
things.
put food in plate.
Exactly. There's responsibilities, and you have to bills pay, you know, job and all those things, career. So the question is how we can help, as you give those examples of, you know, Lee Giat, how we can help majority of the kids to follow through with their passions of being astronaut, getting involved in the space without losing it. What do you think would be a good way?
Okay, so first of all, that is a point when, especially when they become teenagers, they are kind of ashamed to be intelligent because they don't want to be the geek. But right now at this moment, it's not like me when I was a teenager. Probably it's not even like you when you were a teenager. Because now being geek, it's cool. So that is awesome for them. So most likely they will not change. They will not give up of their dreams. And then the other thing is that unfortunately, for some countries where they don't have public education, like here in the United States, you're limiting a huge part of your population to actually reach that dream. Because if people are not going to college, or even when they go to college, if they don't have stable jobs, or if they, you know, they make it too difficult for them to exercise their profession, you end up being a clerk. You end up being, you know, some other thing that is not related to your courses. You kind of give up your dream. So the way it is that, what I think is that the countries that have public education where you can go to college and not be in that for the rest of your life, or the countries that have the chance to have more people available to become that. Now, here in the United States, you have people who have access to higher education, albeit the wealth people or the super genius people, like the miracle in millions. Those can do it. So the basic thing is that you need to be a, you know, excellent student during your years in school, and then after that you need to apply to go to colleges, and you know, very few came from public education. They normally go to big in universities that they are probably still paying the debt, even though they're not even doing their college anymore, because some places when you work in science, you're not employee, you actually are a contractor. So when you have a contractor, sometimes you don't even have health insurance in here, because health insurance here, it's paid, it's not given from your taxes from the state. So there is a few complications, but the basic method for you to become an astronaut or for you to work in that area is a good student in school, especially when you're in high school. And then after that, you need to go to college. And after you finish college, for you to apply for astronaut school, you need 2 years of profession. But I advise to you that you're going to have to try at least 5 times, 6 times. And then while you're doing it, try to still learn more, like get a master's degree, that is a doctorate degree that you're going to make your chance of living even higher. And the other thing that if you really want to be an astronaut, not just, working science or be in the area related, if you actually want to be an astronaut, I advise to you also to not let go and gain weight, because you need to have fitness. You need to have good health. You need to have, so take care of your health, and you have to be a good student, at least from high school on until college. And then I know like college sometimes is like, you need to live a little, you need to have fun. But if you're actually applying to be an astronaut, you need to take it very seriously. Very seriously, because you need to be like the point of the arrow in your class for you to actually go. So it's like from the class of 30 astronauts, you're probably gonna be, most of you are gonna be ground crew, and maybe 2 or 3 of those are going to be chosen to actually be an astronaut. And so from a point of view of the state, a state that gives chance for people to study and to have health, have more chance to have more people available to become the point of the spear. Mm-hmm. But in some countries where they have more resources and everything is paid, only maybe the super genius or the wealth are going to be the ones to actually do that. But or sometimes luck, happy-go-lucky gets to do sometimes miracly, because
the stars align.
What happened to me was a miracle. I am fortunate. I'm very thankful for everyone who helped me to actually get my mission, because I know how privileged and how lucky I was, because what happened to me was very improbable. Even though I have lots of kids who follow me, I have a generation of kids going to college because they watch my lectures. I was their Carl Sagan, for say, their local Carl Sagan. But, they have me to actually give them, let's ask questions. So not that their success is because of me. The only thing that I think that I contributed is ask questions. Question everything and be a good student and apply yourself in math a little bit better. Don't do like me. So it's like you can have a little fun, but you need to take serious college. College needs to be very serious. And then if you apply for the astronaut corps, be sure that you're gonna be rejected many years, but you need to keep going and keep trying. So some of the astronauts got rejected like 5-6 times to actually be called. So you have to keep going. Just keep going, that you might get lucky like me, or because you're super smart and you're very, very hard work, you for sure gonna get it.
Or you can wait it out and wait until the space industry will go commercial.
Sure, but when it goes commercial, you need to have the cha-ching.
Yeah, well, it's, so we're talking again maybe about 20-30 years. And depending on the age that you guys are listening and watching, maybe you will be around, maybe you're 7, so you're definitely going to be around. So, but that's going to be possible.
Or maybe some of those are going to Mars.
Yeah, exactly. What do you think about that scenario? Because that's very interesting. And like I talked with a lot of people, I had them on the show where they're creating space habitats for Mars or for the moon space bases, and they're working on these projects. Some of the people that are running these projects in Hawaii or Poland, analog missions and things like that. So I think this is very fascinating. Spacecraft architecture is another thing that, fascinates me as well. So, but do you think we're actually ready just by getting the feedback from the kids and from people around you? Because I always say, now we have this Earth-like thinking where we boil in our problems and all this juices kind of, running through the same knowledge and everything. So, and now we need to go to this universal thinking where we don't think about, of course we think about our problems, but we'll look further into the stars. So do you think we're closer to that edge, or it's going to be a long time, like 20, 30, 40 years?
Well, it depends of the investment. From what I see now that you have, commercial initiatives, I see that is a huge chance to happen. And the other thing is that you have a little bit more of a fierce competition between some countries because of economical, resources. So things are kind of moving again. So if you also, again, ask me that question, like 2 years ago, I would say, nah, no way, because the government is not giving money to that. But like the point that I saw a spacecraft coming back and landing very slowly, I'm like, okay, now I changed my mind. It was amazing. I was screaming in my house, seeing those two spacecraft
And
landing.
you seen it physically?
Beautifully. I was watching. Yeah.
Wow.
I live 4 hours of Kennedy Space Center, so whenever they have like awesome stuff happening, I try not to work and go. I try, sometimes, but sometimes I can see from my house when they're above like maybe 20 degrees above the horizon. I can see the tiny little light coming in and coming out, so I can see some of the launches from my house, even though I don't hear anything. But right now, yes, I think you're right. That's about to happen. Like maybe, now, for now, what I'm saying to most of the people that if people are going to Mars, they're going to die on Mars for what we have there right now. But if you give a few years to actually construct with robots, put together habitats, and that, we might have people who might be able to come back one day. But you have to be aware that this beautiful cocoon of a planet that ours protect us from all the bad radiation, from space radiation, so cosmic rays, or even our own sun, radiation. So it's a lot of stuff that it is bad for you. And then let's say it's like people in my family, they tend to live around 100 years old. So like, some of my grandmas and grandmas, they go about close to 100 years. So let's say if I am 50 now, I probably gonna live more 50 years in my normal life if I'm still taking care of my health and, no kind of freaky accident. But if I go to Mars, I'm probably going to be dying around 70 years old. I'm going to lose 30 years of my life or even more because the incidence of cancers, of the degenerative disease are higher because I am on Mars and I am being, struck by cosmic rays and solar radiation all the time. So my lifespan is going to diminish.
Well, it could be worse. It could be worse.
Yes.
We can go to the club with the Carlos and live for 10 years.
Yes. But what I'm telling to the kids, so this is what I tell adults, that right now at this moment, we have the technology to go to Mars. We do. We can go this year because we have the technology. We can get there. We can probably, send spacecraft ahead and bring whatever water or whatever you need to survive. Yes, we can. But it's going to need a huge investment that no government wants to pay. So it's going to take some time for you to do slowly. And then also is the risk of the people who are going, they are sure that they're going and they're not come back. So that's another. But for the kids, what I'm saying is that you were already trained to go to Mars because we were a whole year and a half in close quarters.
That's what I say as well.
Connecting with people and learning and doing schooling via computer. So we have a whole trained generation to be in isolation of spacecraft because we did that. Yeah. Let's say you will not have Amazon to deliver your food or whatever, but you will bring that in your spacecraft. So this whole pandemic thing was for us to learn how to do telemedicine, telelearning, whatever we are doing all the time, or just wasting time with Facebook and Netflix. But, we are doing it in close quarters with other people that we need to kind of, deal with the, being in the same people we love, but sometimes they drive us crazy because we cannot leave the house. So we actually train to go to Mars. Everybody's trained to go to Mars. And then, of course, I'm a little bit down because, I'm still stuck here. But it's like I didn't go cuckoo. I didn't, go running naked on the street and screaming and, jumping out of the train or something like that. So probably I'm good to go to Mars. So yeah, everybody actually trained it. So when I tell the kids like, you train already, they go like, oh, really? For us, for me and you, it is a risk. For them, it is a possibility. I see it as a possibility.
So hopefully, because yeah. I have my fingers crossed as well here, because
I think we will see it. I don't think I'm gonna go because even though I'm the same age as the astronautical average age, because that's our age now.
Yeah.
The new classes are coming that may be about your age, but they're not going to Mars. They're going maybe to the moon.
Yeah.
Maybe to, low Earth orbit. That's what we are doing so far. But I think the little ones who are doing, Zoom classes are the ones who are going to go to Mars. And they are already trained. They put in a curriculum, trained to go to Mars, close quarters confinement, doing everything you can put in your curriculum. Because you can prove that you stay stuck in home for a whole year or more.
Yeah, right? well, in this case, you at least you can take your dog for a walk. It's not going to be Mars scenario, So, but
yes, and then the other thing is that as we do it, we're gonna get even more instrumentation that is good for your health, good for your mental health,
Space
good
medicine
for
is
the science, good
field.
for the economy. That is gonna be in your pocket because it's the whole saying: every dollar that you invest in science, $7 return in economic growth for that country. And this proved right after the Second World War. You have all the scientists coming here freely and doing the science here in the United States. In Europe, you have, after, you have the Schengen, that everybody could cross frontiers and cross-pollinate knowledge and have people from everywhere and you learn many cultures. You end up having more rich science that's more human science, less commercial and more like to the side of the population. So that's kind of the cool stuff from Europe that, except for NASA, that everything NASA does becomes public. That's super awesome. ESA does the same. And then most of the public university and institutions in Europe have that kind of inspiration coming from the Manhattan Project, from NASA a little bit later. So it's like, even though United States is not quite follow the right way, it was the United States who started the right way right after the Second World War, where we taught everyone what we knew. And that's how we do things. Like, that's how I do things. I learned teaching. So when I learn something, it's because I taught something. That's, cross-pollination of knowledge, and it is always fun to do it.
So I think it's really beautiful. I mean, to continue to learn and, continue to get as you ask me the question about the ideas, and I'm saying, oh, I have a lot of great ideas. Look, those are not my ideas. Because look, I'm not.
We steal them.
Like, exactly. I'm not any special. I'll just grab it from there, and I just take it together, twist it and tweak it a little bit, and I take it as my idea. But nobody has their own ideas. Mark Zuckerberg.
No, we steal it.
Exactly. Mark Zuckerberg, that story. So we always steal it. So my question is, on that topic, and I know you're not going to love this. You're probably going to hate this question. But regardless who I talk with, if it's engineers from NASA, I always, just from a curiosity perspective, I just want to, check it out and see what these people are going to say. But, talking about the knowledge, which is a great thing. It's definitely a commodity these days. It's an asset. And again, people building businesses online, things are moving, to that direction. And I think I'm a true believer that if we want to solve our problems, we need kind of different knowledge. And of course, that knowledge will come through space exploration and going in this sci-fi scenario, getting third-party knowledge. So let's say something from out there could provide us the knowledge that they already have. They're more advanced in the future. So what do you think about that scenario of more advanced, you know, human beings, the extraterrestrial creatures living out there in the universe? Do you think there's something out there?
Until last week, I would say unlikely. But this week, I was like,
what happened?
I should research a little bit more. I haven't changed my mind yet. Because, you know, as I learn astronomy, you know, the distances are huge. And then for you to cross those huge expanses, and you have the finite, you know, speed limit of light, you cannot move faster than that for what we know so far. But the videos of the UFOs this last week, I'm like, what?
What was there?
I don't know yet. You know, I'm kind of, I don't know. Yeah. So I'm like, what? So I haven't decided yet. I don't know if I have enough knowledge to actually comment on something like that. Because last week I would say to you, the distance is the closest star to us is 4 light years away. So if you're in that star, and if you're in Proxima Centauri and I'm here on Earth, and I say hi, and then you say hello, just that conversation, hi, 4 years, and your hello coming back to me is going to take 8 years. That is a lifetime in a human lifetime.
Yep.
So if the rules that we know so far of physics are still in the same place, that so far that what we know, nothing can move faster than light, I tell you that it's unlikely that we're gonna have contact with the another civilization. So maybe when we finally receive the data in space, the radio data or whatever data is coming towards to us, that civilization doesn't even exist anymore, because stars have finite life too. So 4 billion years, our sun's going to be kaput. Our civilization, this planet, we have an expiration with maybe scientific knowledge and changing the planet. We can still live in this planet for about 1 billion years. If we have just now, with no mitigation, we have 250 million years in this planet. So it's a very finite time for us to live in this nice, warm, with water and a radiation protected planet. So we have a finite day. So it's very short. And now imagine that the data from those civilizations need to cross 100 billion light years. That's the size of our own galaxy. But nothing from another galaxy, just the local galaxies, huge sizes and distances. So before last week, I would say unlikely. That would be my answer. But now what I've seen this week with showing UFOs that go like 20 something G's, and when they go inside the water doesn't make wave. So they're not actually have mechanical influence in the molecules of the water, and the temperature is not changing because they're filming in infrared. And I was like, holy crap. It was a change of paradigm for me that I need just to digest a little bit. Let's say it's not that I didn't like the question, is that I'm still formulating the answer, because last week I had an answer and I had like, unlikely. I had the answer. But this week I'm like, okay, maybe I need to think about a little bit more and research a little bit more and see if they're going to declassify more stuff, because or China or Russia have huge advancement in technology that are way ahead of any other country in the world, or is some kind of spacecraft. And it could be both civilization from somewhere else.
It could be both scenarios, because I remember I had one of the guests previously on a show, and I think I remember the name, and he was talking about that basically he has a buddy of his, and he works in the military, and he said he couldn't tell any names, anything like that. But his buddy said, anything that you can imagine kind of being sci-fi technology, he says, we already way beyond that. So it could be the case that this is military aircrafts that we're seeing, and, you know, because I think that would be scary. That would be even scarier, you know?
Yeah.
So,
But the government here in the United States just pronounced that they didn't have anything. There is not us, like it's not us, the United States. So some other country who have way much more technology, able to move in hypersonic speeds of 26 times the speed of like the best jets that I know go 5 Mach or something like that. And the pilot needs to be you know, wearing an astronaut suit, and the pressures and the G's are not healthy at all. Like you can have some of them moving about that speed without, you know, being like a drones being not being piloted. That is possible because we as human beings, those G's are not good for you. So I don't know. For me, I need more. I'm a data driven person. And I don't like to speculate. Last week, I would say unlikely, but this week, I'm like, maybe. But in my head, because I need more proof, I need more data, but by the way my head works, I'm thinking maybe someone has more science than we do.
But
local. It's local. It's local.
So what would you wish? What would you wish, like going further in the future, just by looking at the data? Would you wish to say no, it's nothing there, or would you wish to say, oh yes, we found this is definitely existing? Like which one would you be leading towards the most? Just from
as a fan of Star Trek, I would love to see something like that. But then as a person who reads history, that could be a danger because, you know, for my people, I born in the Amazon. So for my people, the coming of a more advanced civilization, crossing huge spans of water, in that case, not huge spans of space, crossing, bringing new technology, brought disease, brought army, brought technology that caused a genocide. Yeah, so we have like 200 millions of indigenous peoples in the Americans, and now we have very few people. And we lost the culture, we have lost that knowledge, we lost those languages, and people like me became without culture because by the Portuguese civilization, you were prohibited to talk in your native language. So I don't have my native language. I don't have my culture. I don't have anything because you know, my people were invaded, and I don't even look like because of that. Because then I have people miscegenating and changing genes, and I don't really look the way it's supposed to look. At least I got the straight hair, but other than that, I don't look like an indigenous person. You know, it's all mixed up. But you know what, it's sad. And then when you look at history, so for one point, I would love to see, you know, the Vulcans visiting us and teaching us and changing our culture and make us peaceful so we don't do any more wars, and everybody has the right to have health insurance, food, a roof in their head, and learn anything they want to learn, but for the sake of knowledge. That would be awesome. But then you have to think about it that whenever for the analogy as the example that we have on our own planet, where a higher level civilization visited a lower level civilization, you end up with death, with slavery, with disease, with violence. So it's like some of those aliens, if they are out there, they look at us and they think that we are little insects, that they might not even think that we are sentient.
Do you know the book Hitchhiker's Guide to the Galaxy? Of course. So yes. You know the story. So probably they will come over and say, we need to make this a freeway or something.
The road.
Exactly.
you're in the way. So we're gonna just, cross the what? Okay, so that's the same thing. We could be nothing for them, and it's not that they're malevolent. It's just like when you walk in your garden. Are you aware of all the ants that you're stepping on it? You're gonna go crazy if you actually paying attention where you're stepping on it. Like it's like tiny little insects that you don't even see they are there, and you're doing it.
Or we could be just like an extinct animals that we keep in a preservated, that we have the books and the rules and regulations. We cannot touch them. They're there and we just observe them. This could be the case also.
Yes. So yeah, like we could become a zoo.
Yeah.
We could become food. We could be just, a little stone on the way of the new galactic road. So it's always like, it is one point we could have the Vulcans visiting us and bringing us the new, age in knowledge and peace and in, respect for the human beings and start colonizing the galaxy. That could be one. But for the example that we have, for the historical data that we have, normally that's not a good thing. So we need to be careful to be advertising the, hey, hello, we are here, come and eat us.
Yeah.
Call us. Yeah, so it's like, yeah. So but that would be awesome too.
That would be awesome. Look, and for you guys and girls who are watching or listening to this episode, if you see Helena now, Helen is leaning towards more believing. Is just because she's into the Star Trek series right now, and probably that adds up to the whole excitement too. But it's definitely
Sophia Edith. I even speak Vulcan.
So
it's look, that's what I said.
This is what it is, because we have the famous Drake equation. Of course, there has to be something. Just looking at the numbers, and now recently, as I'm looking at the article here on the phone, just want to read it out so I won't miss it. I
actually know which article you're talking
about the fifth dimension.
To change a little bit
about the fifth dimension, that we can explain the dark matter in the fifth dimension. Now they uncover that, and now what I want to say, that there are probably so many different things in physics, the things that we're not aware about, yet, because we don't have the technology to detect those things. And maybe that's the way those creatures, beings, are communicating, through the levels that we don't have, access to yet. That could be the case. Look, we going into sci-fi, so there could be many cases. Yeah.
But when you kind of if you write sci-fi, if you as you have interest not in the science per se, but if you are an artistic kid that you're going to go into arts in the future, if you write something based in something that's real, when you make your art is better. It's awesome to be creative, but when it's based on something that is plausible, you sell better. That's not just to yourself, but for the people who are going to fund your project. So it's like, it's always good for you to have that knowledge in science too, if you're an artistic person, because then you can apply that knowledge, and that not just apply that knowledge can inspire you to something that even no scientists even thought about it. Yeah. And then we can see cross-pollination from art going back to science, because communicators started in Star Trek, and now you have a communicator in your pocket if you're allowed to, or your mother has one. So it's like you have the cross-pollination, that we need not just the scientists, not just the politicians, the doctors, being able to have an analytical mind and have, asking questions. The artists are necessary too, because they're at that point of inspiration, that idea that's going to be in the movie is going to inspire a kid who's going to be the next scientist, who's going to discover something amazing. And
we need Steven Spielberg for sure.
Yeah. And then, as you just mentioned, new ways to see the universe. 4 years ago, we had no idea that we could only see the universe using electromagnetic waves. So you see radio to X-ray, gamma ray, and all in between. Now we have gravitational waves with the LIGO experiments. That's another way for you to see the universe. that is a new window that opened, because everything that I study, everything that I saw in college is all about the electromagnetic waves, electromagnetic spectrum, especially when I was doing, analysis of plants to discover the chemistry of the plant. By the way, it's the same instrument that you put in the back of the telescope to know the composition of a star. So the science, it translates perfectly from one to another. But when you get that science, and now that is another way for you to look at the universe, not in an electromagnetic spectrum, but you can actually use another way for you, another window, another pair of glasses that you can actually see now the universe in gravitational waves. You can actually pass the dark ages of the universe before the first stars coming about, and you might be able to see the formation of galaxies using using gravitational waves as the new instrument to see the universe. We just opened that door. That door just gave a Nobel Prize, not 4 years ago. We just discovered, like maybe 6 years ago, the Higgs boson. So you have like new discoveries that came in the last 10 years that is changing the view of the universe every day, and then takes people like you or me to actually translate that thing into something that, the regular person who is actually putting the politician who's going to get the funding for the science to be done can understand.
Yeah.
So the public needs to understand, because the public funds everything.
Yeah.
Doesn't matter if it's commercial or state sponsored, because or you're going to be a consumer or you're going to be a taxpayer. So if the public doesn't understand your science it will take longer to have a use. So if you can get the people who publish the data, who write the papers, to communicate, or you can get people to explain to communicators, to actually explain to the public, that's when you get more funding for the next generation of research, for the next generation. So science communication is very important. So for those who are my ex-students and for my ex-trainees at Fox, I advise you that if you're going to career pure science, if you're going to do your science, please do a writing course, do a public speaking course, because if you want your funding for your science, if you want to find your job, if you on your job you want to go to higher levels of payment or higher levels of funding for your science, you need to communicate your science. Yep. So you need to write well, and you need also to talk well, because some people read the gobbledygook, even though it's a good writing, and even though it's fun, even though it was nice writing, some people cannot pay attention to that. Yep. And then you need someone to have linkings in their hand trying to explain what those numbers mean. So you need to public speak well, and you need also to write well. If you don't write well, at least learn how to public speak to actually transmit your science, because that's when you move ahead your science.
And that's a really powerful message, because again, as I said, it's going to be through those science communicators. And the thing that excites me the most, and again with this entire pandemic situation, that so many people started Facebook groups, podcasts, and just like mine, and I don't look at these people, and I think that's why I love this community, because again, as I mentioned, I have a completely different podcast. It's all about business, very serious. I get to talk with serious people, and they look at things very serious. But here, everybody, look at, if it's other podcasts, other science communicator is as a friend. It's not a competitor, because it's we moving towards a cause and a mission that unites us all. So, and I think that's why, again, we need more people. And I say that at the beginning, at the end of the show, we need you. We need people. We need people to continue to, if it's through astrophotography, if it's through space engineering, science, whatever that might be, but just taking the first step. And again, in the times where the COVID is, and a lot of people looking to change those directions, and when it comes to career, maybe it's the time. I'm not saying go full in,
yes.
But maybe it's the time.
Maybe it's my time now.
Here you go.
Change career again.
So where would you go now? What's the good place to go with a career?
I don't know. So it's like, I want to do what you're doing. Talk about science,
Very
but I
easy.
don't know where to start because I've been doing that as like mostly not paid, or if paid, mostly it's just for, you know, hotel presentations and,
Mhm.
you know, just the compensation of like momentarily, nothing that is like paying me for doing that.
Mm.
And that will be a dream come true. Another dream come true is to actually put food in a plate using science. But it is like right now at this moment, everybody has a podcast. So
Mm.
I think I'm late in the game
Ah,
for me
no,
to start. I don't know.
look,
And
the
I
what
don't even know where to start.
look, I'll help you. Look, I'll help you. I'm here. I can help you. You know, I can give you a lot of insights, guidance into that. And I would say that for everybody. If somebody leaves a comment and you want to start a podcast or you want to do something like on TikTok, like SpaceXplr has
I don't even
180,000.
have TikTok.
Here you go. Neil deGrasse Tyson has a TikTok. So maybe it's time to have a TikTok.
I only have Facebook because I need to manage the Facebook page from Fox Observatory. I could not be a manager if I didn't have my own page.
Just for that
And that
reason.
took over my life. I hate that day.
Thank you actually, and you're already hooking me up to the people in the comment section, so I really appreciate you for doing that. Even off the record, even off, you know, on social media, Helen has continued to make the science and, you know, collaborate with people, make the connection. So, you know, so you're a really great science communicator, and again, I so appreciate you for everything that you do. Again, the stars, as we talked about, aligned for you perfectly. So you worked with the Sophia, that project done. Next, I think
Yeah,
a lot of great things will unfold for you. And if I can be part of that unfolding process,
yes,
I'll be happy to do that as well, you know?
sure. So that is a new project that one of my trainees are doing is Passage. Passage is
Mhm.
an airplane that's going to travel for South America, bringing material for teachers who have no resources to actually teach science, especially
Mhm.
astronomy, physics. So he's actually doing a double major in communication and I think physics,
That's
but I'm
Lee
not sure.
Giat, right?
And then he's was one of my trainees, and he has like a presence online, and he does videos, and he's super smart, and that would be an awesome person for you to actually, you know, interview too, because he did the training on the, you know, for astronaut in Russia. And another person who's doing that is Monroe, the one that came in early in the call. He's probably getting ready for his own. And he is doing this for probably as long as I am alive. He's doing outreach in astronomy. He's one
Wow.
of the people who began in at Fox Observatory. He's like super smart. And he is saying, like, you don't call him geek or nerd, you need to call him polymath. So
Oh.
that's why he says polymath, because he knows anything about anything, everything about anything. It's like physics, chemistry, biology, and he was computer engineer. You know, so he did, you know, healthcare, programming for, you know, stuff. So that's another person that's cool to actually interview and see that how he applied the knowledge that he had in his engineering into. And then the other one is his space case with the Muhammad Yassi, as he's like the other content that I gave to you. It's like he's been doing this. When I started on Facebook, he actually communicated with me because of Sophia, and I started following, you know, his posts. So we are friends in Facebook. I have never even talked to him. We just write and, you know, go and
Yeah.
posting. That's another person that's doing like cool stuff in other country and, you know, doing cool stuff. So yeah, I think we're becoming a generation that is using this platform a little bit more.
Mhm.
And then that's bringing the new people with the new technology, the new TikTok people, like, you know, I don't even know how to pronounce that. I'm sounding like an old lady now, but you know, that's the new stuff. It's cool because it's another platform to clarify people that they need to have critical thinking. It's
Yeah.
basic. All we're doing here and all you know, what we are doing is all basic knowledge, critical thinking, because you need to ask the right questions, not just for the science, for the
Mhm.
technology, for the everyday life, for
Yeah.
all interactions with people you know, with the interactions of people who represent you. That's very important. So critical thinking is like, you know, the most important thing that we are doing here right now.
Gotcha. So another note for me to keep,
Oh, by the
because
way, if you want to ask any questions, or if you want to make a video of me exploding comets or doing silly things, contact me on Facebook, because that's the only platform that I know how to use. You have to remember that I'm an old lady. I
oh, come on.
barely know how to use Zoom, because normally I have people controlling Zoom for me. I just ask, can you do this? Can you do that? And they do that for me. So I don't know how to do it. And then basically, if you want to contact me to do any silly stuff, but I am not afraid of being silly for science. That's my superpower.
That is awesome.
So, you know, like, you know, wear, you know, star earrings or star, you know, berets, and, you know, star dresses, and, you know, I go all the way. I'm not afraid to be ridiculous. And if it is for science, that's my pleasure to be ridiculous. So, you know, and then the other thing that you get is that we need more people from all genders and orientations to be in science. For now, in my generation, it's a boys club. It's like, if I come there, I need time for them to get used to me, because I am not just, you know, the girl in the club. I am noisy too. And, you know, so I'm annoying. And then he comes the annoying girl. Okay, yes, but I'm going to be there and deal with it. But then when you have someone like me, or some of the female instructors, or people from, you know, all different kinds of representative groups, being part of the science, being on the camera, being explaining thing, you actually allow half or even more of the population who is ashamed to be smart, but is smart. People who are shy, who don't want to call attention, people who have different cultures that are, you know, it's dangerous for them to call attention, especially they are female. So when you have someone like me, or someone like other female scientists from those other different countries that have, you create a new generation of people who never hear those minds. So imagine you're throwing away half of the minds if you're not giving opportunity for women to have the family, have the kids, and do science. Because I had to do choice, so I have no kids. Because I have no time, I have no resources. What I was doing didn't pay enough for me to actually, you know, the sacrifices that we're doing for science, it didn't allow me to have a family. So nowadays, you should not have that. You should have everything. And then in the case of my mother lived in the country. I gave health insurance, allow her to study for free, allow her to have a huge profession with good salary. So she could be a scientist. She could be a nurse with high level degree of knowledge, do her mission, who work in the army, have her mission, and also have kids and raise them well. So when the state helps you, it's even better. But when the state doesn't help you, when the state is like, you know, much more liberal, that is no help, no safety net, that makes harder for you to have a family. So you need to make hard choices. So now I need to contribute to put the next generation of female scientists, to allow them to have everything, to have their career and have the family, or not have the family by their choices, or, you know, it's like, just allow them to be, because those minds are valuable. From those minds, you know, my life is going to become easy with something in my pocket. So it's, we need to, that's necessary for the next generation. And that's my legacy. That's my function. What I see me doing is bringing people to telling them, you are allowed to be what you want to be.
And that's very powerful, because again, you cannot enforce people to, you know, to force people to make decisions that they don't want. And, you know, there's a lot of ladies, like I had a lot of ladies, and I'm looking forward to having more, because, you know, especially with the other podcasts, when I talk with the ladies versus guys, the ladies somehow seem to be more professional. And I tell that, and I tell that every time to them. It doesn't matter if I talk with a guy, I'm like, you know, the ladies actually are crushing it. You know, they're doing super great. And a lot of these ladies, science communicators, ladies who are involved into building habitats and, you know, having analog missions and things like that, you know, there's a lot of great women who do a lot of great things. And again, but, you know, there's that problem too in astrophotography community where, you know, ladies get picked on for whatever reason. Like I talked about that. For me, like it's mind-boggling, because at least in this industry, as I talked about, not having competition and everybody's just kind of on the same level, you know, field, and everybody's looking towards that big mission, and, you know, everybody's kind of united. For me to hear those stories that, you know, women get picked on for whatever reason, oh, you're women, you don't know how to do, you know, it's still, you know, bothers me a lot, you know, because I'm married. Like,
because you have your related females in your family, and you want to be them to be treated, you know, the way you expected. Yeah, I agree with you. Yeah,
it's you know, it's I think as you said, it's a learning curve in all the situations. So we need to learn from that, but we have to teach that by example. So
yeah, yes, yeah. And then the other thing is that we still have a problem in some countries that when a female is the boss, she's forceful, she is a B word, she's, you know, it's always a bad connotation that she's a witch because she's bossy. No, when he's a man, oh, has the pulse in the things. He is efficient. He controls his employees. So there's always good connotation. So that is a change that's coming. It's coming. The new generation, the people who are younger than us, they are actually like that. They don't want a gender signing. They don't want it, they want to be neutral in everything and receive everything. And I found it's really beautiful, and I'm actually learning with them, because I am, you know, a little bit, you know, old school, and it's like, oh, this is just strange for me. But no, it's like they are open for everything. They don't even want to say, oh, I'm a female, I'm a male, or whatever. I am that person. Doesn't matter which gender it is. I'm Helen. That's it. You know, it's like that's beautiful. The new generation is awesome. You know, like I have some kids who are, you know, greater Thumbe followers, and they are doing, you know, the environmental stuff, and they're amazing. When I grow up, I want to be like them. You know, when I grow up, I want to be like Greta.
Exactly. So, and I think what you're talking about is very promising. If you receive that, you know, that type of information, data that you're collecting, you know, from these kids, and these kids are moving towards like being very neutral. I think that for me at least sounds what I'm talking about, having Earth-like thinking versus universal thinking. It sounds like it's going to become this universal thinking, which is very promising, because one thing that unites us all, that we're all humans, right? So if you don't have no gender, all your women,
like the Ferengi say, humans.
Here you go. So, you know, it's very promising to hear that. Yeah, at least.
Yes, it is. It is. I hope it continues, because when they get to the commercial area, when they go to college, then they have mentors that actually retrain them. So I hope it doesn't change, because I've been hearing that since I was a teenager, and I thought by my time I wouldn't have any kind of problem, and I did have. And I feel like a little bit of progress came, but you know, here in the United States, still women makes like, you know, a fraction of $1 in payment for the same job as a man. So that is those kinds of structural discrimination that's hard to move, because you need for the old people to retire and not train the new generation. So that's like, you know, when they train the new generation, of course they go for whatever is more valuable for them. If I'm going to make more money being like this, they're going to do it. They don't care about being neutral. So I hope this generation, that those teenagers that finish high school and just beginning college, they keep the way they are, that universal thinking. I hope they don't change when they gets the time for them to work in 5 years. Let's hope they progress a little bit more.
Well, I think they will. And again, if we have the momentum with the space industry, with all the ads and marketing that we're seeing, that will help. The social media and like leveling all the people without genders and everything, kind of, we're all humans. That's the famous song that came out that probably got like 100 billion views. I'm only human overall, like don't put a blame on me or something. That's what it is, and that's why people love it, because everybody's humans. But I think another piece that will help us to go towards that faster is jobs. As we're talking about jobs, and a lot of that discrimination is because we live on a planet where we need money to survive. Most of the time we want to live comfortably, dress good, maybe we want a fancy watch in some cases or something like that. But we need money, right? So, and having, technology just like AI, as people are scared at the same time, I do understand, because there will be industries that will be closed for people, because there will be machinery only. Because look, where you have a machine working 24/7 instead of a person working 8 hours a day, and he's going to be complaining most of the time, it's not worth it. And you can write the machine off. So it's far more better to have that. But that will open space for people to go and actually do things that they feel passionate, creative about, painting, music, anything like that. And I think with that, and we see those like websites like Fiverr or anything, you have people like freelancers. I think some of those people, maybe not all of them, but at least probably majority of those people feel really happy because they receive something, they do the work, and they live and they do whatever they want. And that's where you don't get the criticism, or you're a lady, you're a man, or whatever. So I think with that time, with the AI, is going to open up a lot of that free time that people can actually go and explore and become more freer.
Yes.
Because I think majority of the limitations are here for the people. And that's where the people are stressed and they point fingers, blame people. So I think it's going to be good. But again, we just have to be patient with it for now.
Yes. Yeah. But then that is going to be a point that you have like the conflict of people losing jobs because of that. And then, that is, and then they go and ask the politicians to stop the change. So it's like, it's back and forth. Yeah, but it is. And so have you ever watched any video from Rutger Bregman or read any of his books? He is advocating to have Rutger Bregman. He is a social scientist and journalist, and he is actually advocating for minimum salary for everyone, like universal salary. Mm-hmm. So then people who are working in dead-end jobs, they're not bringing them happiness or any, they don't have to. They can or stay at home and play on Netflix, or they can actually go back to school and study or be independent or found something or do their dream art or doing like that. So it's something that will be in the future necessary, because just what you said, that the technology is advancing so much that most of the loss of jobs, like it's for automation. For automation, all the loss of jobs that we saw before the pandemic, all the loss of jobs was automation, not just automation of mechanical things. Those AIs and those algorithms that were making bots online that would substituting journalists, commentaries, people who are aggregating information. That is done by AI. So it's already happening. And those loss of jobs were huge. And then the changing of the media, instead to be newspapers and TV, now it's the media that we are doing right now, that's totally decentralized, totally out of control. And so, like, for one thing, brings people like you and me to people who would never even hear about us if you didn't live here in Florida and visit the local observatory. So we would never met each other if it wasn't this technology. So it's decentralized. It is scary a little bit because a lot of the journalists lose their jobs, but in the other way, it brings more information to everyone. So what Rutger and all the people are doing, that he reads like real data from historical archives to show that, if the state gives a minimum salary to everyone, it brings more economical resources, because the jobs become better paying jobs, because someone will not leave the house if it's a decent job. So you avoid that kind of almost a slavery kind of job, that you need to keep working to survive, and you have no time to raise your family, you have no time to do anything. And then he is advocating that, and also for the rich to pay their taxes. So that's the two things that he speaks, and he spoke on Davos and mentioned that. And then it goes back to people like me, who instead to go and follow my calling to science, I end up being a clerk because I need to put food in my plate. Even though I was diplomatic clerk and I was doing cool stuff, traveling and speaking different languages, but even though I wasn't doing my science, I was, just looking at documentation. And so it's like, if I had a chance to actually be some time to actually invest in my education, not actually be forced to work to survive, I would have contributed more in science, even though I know that I'm contributing in science, not through me directly, to somebody else's education that I'm helping. But, it's like what he advocates, to have that, basic salary for everyone. So no one will be in a situation that they are obliged to work in a horrible job where they are suffering violence sometimes, or, that not paying enough for them to have a decent life. And then, making all the other jobs better, or giving opportunities, and then bringing someone who would be stuck in a dead-end job, who is a genius, but you don't know, because he's doing something menial, like, stamping a paper or cleaning a toilet, or, doing something that's menial, because he never had a chance to actually continue education or realize the dream. Doesn't matter if it's in science or it's in art, or, any kind of education, or writing a book. So it's like, those opportunities to change the world.
Money is a big driver. I mean, money is what drives the world.
Not even too much money. It's just to have a decent life.
It's, I always give an example to the people, because I've been asking questions of the employees of NASA who've been on the show. I'm like, is NASA paying well? It's like, I don't want to talk about that. And you always kind of teasing people.
When you're in signed contract, you cannot say it.
Yeah, no, that's I'm just joking around with those people.
Along with the contract, I can mention that most of the jobs of the government here is contractor.
Yeah.
I was working for the government as a clerk, as a diplomatic clerk, as a contractor. Of course, I had health insurance and stuff. It was good, well-paying job. But most of the people who work for the government don't even have health insurance. So it's like, what? You're doing science, you have like 3 doctorate degrees, you're super genius, and you're gonna have to abandon your science to work in Wall Street, to put your family to school, to put food. So it's sad, because we are looking huge brains. We are losing huge brains because of that.
And that's what it is. That's what it is. The
growth of the planet. So imagine all those people who are right now cleaning a table, or cleaning a toilet, or stamping a paper with a stamp. Imagine all those people were doing their dream job. We would be in a technology in this planet that is way much more advanced than we are right now. I am sure, because when you do things by inspiration, you do better. You have ideas that no one could ever think. You bring innovation, you get paradigm change. It's like, we need that. We need that. Unfortunately, money runs the planet. But I think the civilization would be more advanced if the state took care a little bit more of the citizen.
So yeah, now it's the question, how do you change that? Because this is so true, as I said, asking NASA employees, are you getting paid well? And just kind of teasing that. Look, I can talk. This is my show, so if I want to talk about aliens, I talk about aliens.
You can talk, but
I give them example. Sorry, I just want to say, but I give them an example of why do I ask them the question. I'm asking them the question not just because I'm looking for an answer. I'm just teasing those people. But what I tell them later, I tell them the story that there is a guy, his name is Jim Simons. He runs a hedge fund, actually is a quant fund. And, that is probably the most successful quantitative hedge fund in the history. Because of course it's algorithm driven, and he has the employees who are the top scientists who are working for NASA, and now they're working for the hedge fund because NASA pays whatever 100K per year. Let's say if you work in a certain position and you're gonna get paid in a quant fund, you're gonna get paid probably 6-7 figure per year.
$100,000 is rare. It's about $6,000.
So look, the decisions is very easy for those people because they are driven, again, they're money driven people because they want to live comfortably. And if you have brains, if you understand the way economy works, and if you have capabilities to earn that type of money, and of course you can do groundbreaking research by working for NASA, but again, nobody pays you to do that stuff. You know, you get equally treated just like the other guy who is just kind of winged it through the university. What's the difference?
Yes, yeah.
You know, so.
Yeah, that's true. But you know, when you're a contractor, you have very little. So they're employees, they're well-paid employees in NASA. Normally it's the legacy, appointed people who have, good salaries, the people who are employees for a long time that nobody knows what to do, that specific guy is the only one who knows how to do it. Some people are the employees of the legacy stuff, but most of the stuff right now is contractor, and then also that you are paid by the universe that you work. So as like they put together a union of universities, and you being the employee to do the mission, but the employee, so I was Fox Observatory doing a mission on SOFIA for NASA, so as a communicator. So it like most of the stuff is like that here. Most of the universities here, the big name universities, the teachers don't even have tenure. Then some of them don't even make enough money, and then you're paying thousands and thousands of dollars of tuition, and you're being taught by students. The post-grad students are teaching the other students instead to be because the doctor, the one that has tenure, he wastes more time writing papers and get funding for research than actually teaching or doing something else. Because over here we say, if you don't publish, you perish. That is like one of the phrasings that the scientific community says here. Because unfortunately, when you do, love job like, science or education, that is very little respect. And then unfortunately, we have the brain drain from those areas to hedge funds, to, other, enterprises. I'm glad that, Elon Musk, even though he's doing that, but for the money, he's getting those genius people to work in their dream jobs. At least they're still working in their dream job. He opened up, a generation of new jobs for the new guys who are super smart. They're being working. So I'm glad that, all those billionaires that started on the internet, they start with, PayPal or, all the other, mafia of the .com boom. The ones who survived are the ones who are investing on space science. So, and then they're giving opportunity to some of those new scientists to actually still work and make money in their professional, and not have to be like most of us who had to change from science to food in a plate kind of job.
Yeah, so this is a problem that has to be, I think, solved. And part of that, because we can look at people like Elon Musk or somebody else and sit back and wait, okay, let them or time itself to solve these problems. But I think we have to be part of the change. And I think part of the change, as we talked about, bring in community, because by the numbers, and we proved that many times before, in different history timelines, that when people unite in big numbers, we can make a big impact. So, and that's why I think, again, through space science and through that science communication side, we can probably, find the right answer to equally getting paid, or, you know, we can solve that problem as well. But of course, it will take time, and for sure, many more people to do
Yes.
exactly what you do. So, you
Yes,
know, look,
I'm counting on my students to be my future bosses.
here you go, here you go. Look, there's no shame in that, you know, because look, it's everybody, you know, adds to this big thing that's going on, like this soup that's, you know, boiling, and everybody just puts the ingredients. But we know the kind of the recipe. The people who are in this industry, they know the recipe, and they know how to add the certain ingredients that will get us closer to eating that meal, you know. So you're communicating science in a really fun, entertaining way, and I think that's, again,
Messy experiments.
yeah, we definitely need to have this private conversation about you putting YouTube channel together, or podcast or something.
I have a YouTube channel, but I never post any of my videos. I only put the videos that I like. So it's like I have a YouTube channel, but I never used it.
So it's time to rebrand it.
Yeah.
Here you go. Here you go. Because we need to include some links, again, for you guys and girls to connect with Helen. And of course, you're going to find Facebook, or, you know, links to Sophia, you know, any available materials, you know, for you to read through, to watch. But look, make sure to get in contact with Helen and ask her questions about science. If you have any proposition, I'm a big proponent. Look, making, you know, connections with people, collaborating, look, it's really powerful. So it may be working onto something interesting, special, and I think Helen could provide value to the projects that you're working towards to make that connection, because that's how we all move forward. You know,
I'm cheap. Most of the stuff I do is for free.
Here you go. Here you go. So look, it's really awesome. I appreciate you, Helen, again, for coming on today, and hopefully we can do episode 2.0 in the future as well, and discuss a little bit more of the space science. It's been super fun.
All right.
Thanks a lot.